On the last day of August 2019, another powered parachute pilot named Keith Haggard and I took off from a trailhead parking lot about 5 or 6 miles north of the entrance to Arches National Park. We climbed out to about 500 feet above the ground and headed west over Utah Highway 313 that leads to the Island in the Sky district of Canyonlands. We climbed even higher as the ground beneath us rose toward Dead Horse Point State Park. The land we were flying over is part of the Colorado Plateau. This is some of the most remarkable and geologically complex territory anywhere. It's a land of tortured sandstone, of vast mineral deposits such as uranium, petroleum, coal, and minerals like phosphates. But most of all, it's land that is some of the greatest scenery anywhere, well worthy of being preserved for the future as two of America's finest national parks, Arches and Canyonlands. Not long after turning south along our route, we found ourselves over a number of oil well drill pads connected by a network of pipelines. The day we were flying, I could see one of the wells spouting a gray cloud of some kind of fluid about 100 feet into the air. I was about a mile west of that pad, but could smell a very strong odor of gas and oil. I was very curious about what was happening over there, but decided I'd better not get too close. And because flying over a park or wilderness area may disturb people on the ground, we remained clear of Dead Horse Point and Canyonlands throughout the flight. And what better way to see those places than from a powered parachute, a little aircraft that cruises at 30 miles per hour with nothing but sky around you and the earth below. North of the wells and just east of Dead Horse Point, we suddenly flew off the edge of a structure called the Moab Dome. There, cliffs drop a couple of thousand feet down to the Colorado River. The ancestral Colorado was already well established when tectonic forces began to push these rocks upward during a major mountain building period in the west called the Laramide Orogeny, about 70 to 80 million years ago. As the rocks were shoved upward, the great river relentlessly kept carving downward, creating the winding canyons we see today, canyons that followed the ancient, twisting pathway of an elderly river. One of the most geologically intriguing features of the Colorado Plateau is its remarkable stability. Relatively little rock deformation such as faulting and folding has affected this high, thick crustal block within the last 600 billion years or so. In a few places around Utah, volcanic domes in action have disrupted some of this, but mostly it's just a pretty stable plateau. The area was covered several times by warm, shallow seas. Thick layers of sandstone and shale were deposited in the warm, shallow waters of this advancing and retreating seaway. At other times in the geologic past, these lands were vast deserts in which wind-blown sand dunes, thousands of feet thick, slowly turned to stone. The exposed geology of the Canyonlands area is complex and diverse. 12 formations are exposed in Canyonlands National Park that range in age from Pennsylvanian period, 318 million years ago, to the Cretaceous, which ended about 65.5 million years ago. That was the time when dinosaurs roamed here, and lush jungles deposited layers of oil and coal. The oldest and perhaps most interesting layer was created from evaporites deposited from evaporating seawater. Various fossil-rich limestones, sandstones, and shales were deposited by advancing and retreating warm, shallow seas through much of the remaining Paleozoic era when life was still evolving on Earth. As we flew past some of these amazing places, I couldn't help but wonder whether any human has ever stood on top of one of those pinnacles out there. But anyway, as we flew off the cliff edge of Moab Dome near Dead Horse Point, we were surrounded mainly by red Wingate Formation sandstones. These drop down well over 2,500 feet to the river below. The Wingate produces characteristically blocky structures with vertical cliffs and sharp corners. We'll be taking a look at another sandstone called the Entrada, and I'll point out some differences between it and the Wingate. So remember what Wingate looks like here. And remember that when we look at the Entrada later, that the Entrada is actually a younger rock than Wingate. It should be on top of the Wingate, but for reasons we'll see later, it has been eroded away, leaving the Wingate as the top layer that we just flew past. Tectonic activity through the mid-Cenozoic time started to unevenly uplift and slightly tilt the Colorado Plateau and Basin and Range Province area to the west of us some 20 million years ago. Rocks in this area were shoved together under tremendous compressional forces, which caused them to dome upward. As much as 1.8 miles of uplift occurred. This was the result of the entire North American continent being shoved toward the west as the Atlantic Ocean widened. While that was happening, streams had their gradient increased, and they responded by downcutting even faster. Headward erosion and mass wasting helped to erode cliffs back away from the faults, widening the basins in between. Some plateaus have been so severely reduced in size this way that they become mesas or even buttes. Bending of the rock layers resulting from uplift created some complex and puzzling geologic structures. As we dropped down into the Colorado River Valley, our eyes were drawn toward these swirls of blue that resemble an artist's paint palette. This is the big Moab phosphate mine, where phosphate ore is separated from waste rock by being dissolved in water and then harvested by evaporation. We dropped altitude over the ponds because Keith wanted to check out an old landing strip that had once been alongside the river. But it's overgrown and unusable now, so we turned northeast along the river back toward where we had started. Keith swung around and flew over the top of me for a moment as we were passing through this area. Kind of fun to get a look at another machine up close. You've probably noticed that there's a big difference in the ground beneath us now, the land surrounding this territory and what we had flown over a little bit earlier. Now we're down into the valley that was cut by the Colorado River as it wandered back and forth over eons of time before the last period of uplift caused it to incise even farther down. And so what we're looking at here are softer rocks that have given geologists some real challenges in trying to figure out just exactly what the story is here. But places where what little moisture does fall here, what rain and snow does come down, has slowly eroded its way in and formed side gullies that lead into the great river. Now here's one of the meanders of the Colorado River. Remember that old rivers on flat surfaces wander back and forth in what are called meanders. Well, the Colorado was an old river until suddenly the Laramide orogeny began shoving this land upward, while the river kept trying desperately to cut its way down. A lot of the rock we're looking at down there now are the Entrada sandstone. Unlike the Wingate sandstone, which tends to form blocks and cliffs, the Entrada is a little bit softer, and so it tends to erode into rounded shapes. And where this land was pushed upward, the Entrada cracked along narrow fault lines as a result of trying to be stretched as the doming process took place under it. In those spaces between the cracks, we have what are called fins. And as weathering, frost wedging, and other chemical processes and physical processes weaken the rock in the fins, sometimes gravity begins pulling chunks of the stone away and form an arch. As we flew along here, things began to get a little bit interesting because the wind was blowing across this lumpy land underneath us and was making the sky kind of lumpy too. There's Keith down below, heading up past the Colorado and into the formations of the Entrada sandstone. Cruising along a few hundred feet above the ground at just 30 miles per hour gives you plenty of time to look around and enjoy and study the scenery below you. Even when the air is a little bit lumpy. Now we're over the Entrada and flying up along through some box canyons and complex geologic patterns that just defy the imagination. I mentioned earlier that the Entrada sandstone is the stone that forms the arches of Arches National Park. Well, here we are, we're flying over an arch right now. Down at the bottom of the screen in the center, you can see Corona Arch. Corona Arch is 104 feet across and 105 feet high. Well, it's kind of disappeared here for a moment. Let's wait for it to come back. There it is, right smack in the middle of the screen at the bottom. The arch itself doesn't show up very well, but you can see its shadow extending off to the left. Looking at these narrow canyons back through here, can you imagine how easy it might be to become lost in this place? That's why Grand County has some of the most active search and rescue teams in the entire state of Utah. As we flew northeast, we came back to Highway 191 and over the entrance to Arches National Park. And right here we're looking down on the results of the Moab Fault. The highway and the visitor center and employee housing at Arches is basically right on top of a major earthquake fault called the Moab Fault. To the west of the highway, in the left side of the video, is a cliff that ranges nearly 2,000 feet from top to bottom. And remember that the rock to the east of the highway here, to the right side of our screen, or right straight ahead of us at this point, should really be on top of the cliffs to the west. After the faulting occurred, I guess that the Entrada sandstone, which once lay atop the wind gate, was probably just eroded away more rapidly because precipitation tends to be a little bit greater at higher elevations. And there's a difference of about 2,000 feet of elevation. Right there over my right toe is the parking lot and visitor center at Arches and the highway winding up into the park. If you've driven up here, you have some idea of the amount of vertical relief that we're looking at down there. But from about 1,500 feet above the ground, that relief flattens out, doesn't it? Okay, now we're turning toward the northwest over Highway 191. And to the left, you see the escarpment that was caused by the Moab Fault. Well, one last look back toward the visitor center and parking lot and that road again. and out across arches and Entrada sandstone. And then to the left, there again is that cliff, topped by Wingate sandstone and other formations beneath it, some like the Chinle and several others down there. To the left of the highway is a railroad spur that was used to haul waste uranium tailings away from the edge of the Colorado River at an EPA Superfund site. Anyway, following the long process of uplift here, when the land was in compression, the Atlantic Ocean's expansion slowed, and tectonic forces far to the west began moving North America to the northeast. This went from compression to tension, and it was pulled apart toward the east and toward the west. The result was that break in the rock layers that caused those on the east to move downward in relation to those on the west. So when we're flying around Moab, we're looking down on landscape and scenery and incredible beauty that's been millions of years in the making. A landscape and scenery that's now being modified by the powerful hands and machinery of humans, as we enter what geologists are increasingly recognizing as a new geologic epoch, the Anthropocene. The age when Earth is responding to an entirely new and powerful force, the humans. So Keith and I finally returned to that trailhead parking lot. Watch closely here in a moment while Keith lands, while I fly the downwind leg of my landing pattern after a flight of 48 minutes and 29 miles. I can't think of a better way to spend a day, and I want to thank Keith Haggard for shepherding me on my first real cross-country flight as a new powered parachute pilot. And I thank him too for having the good sense to ignore me when I told him that he didn't need to call 911 to come take care of me. But that's a whole nother story. So, I hope you enjoyed our video, and whatever you do, keep smiling.